Looking at this graph to start with, we can see that this line intersects this circle, this red circle, the blue line intersects at these 2 points. This point being -2, -1, and this point here 0, 1. We can see there. When a line and a circle meet, as we know, when any line and curve or 2 lines meet, the points of intersection, the x and the y values are the same. In other words, the coordinates satisfy the equations of both. So if we substitute these coordinates from this point into the equation of the line, we can see that it works, that the right-hand side is equal to the left-hand side. And similarly, if we put the x and the y value from the coordinate pair into the equation of the circle, again, it works. We get the left-hand side equal to the right-hand side of the equation. So both equations satisfied by the point -2, -1. To find the points of intersection of a line and a circle, we need to solve the equations simultaneously. So very similar to what we did recently with lines and curves. So looking through this example here, we'll put x plus 1 in for y. This is what we're putting in. So we need to simplify it and then make it equal to 0 on the right hand side. So we've got this part here. You can see here that the x plus 1 minus 1 is going to just equal x squared, isn't it? The plus 1 and the minus 1 will cancel. So we can simplify it to this. If we then expand out this bracket, we get x squared plus 2x plus another 2x plus 4, which gives us x squared plus 4x plus 4, then plus x squared. And then if we subtract 4 from both sides, we get -4 on the left-hand side, and it leaves us with 0 on the right. Tidy this bit up. We get 2 lots of x squared plus 4x plus 4 and -4 cancel. Observing the discriminant, we can see in this form we've got our a value is 2 because it's ax squared plus bx, so our b value is 4, and we haven't got a c, have we? So c is 0. So here we've got b squared minus 4ac. So we get 16, which is positive, which tells us that the equation has 2 distinct real roots. So we take the x out. We can also take 2 out, can't we? Because 2 is a common factor of 2 and 4. So take 2x out, and that gives us solutions when x is 0 and when x is -2. If we now sub in these values into the linear equation, we can find our corresponding y values. When x is 0, y is 1. And when x is -2, y is -1. If the line does not cut the circle, there are no points of intersection. So if it's quadratic, we get no solutions when the discriminant is negative. So if we consider this line and this circle here, same process as before. We sub in the x -1 for the y here. This time we get this. Tidy it up. We end up with this quadratic here. and the discriminant is minus 32, it's less than 0, which tells us that there's no points of intersection. So this line will miss the circle. It won't intersect or even touch the circle. So there is a third possibility with the discriminant. We've looked at what happens when it's greater than 0. We've looked at what happens when it's less than 0. If the discriminant is equal to 0, then the lines are tangent to the curve. It means it has equal or repeated roots. Again, like our quadratic curves and our straight lines we looked at previously. So to summarise then, these are the three different conditions. If there's 2 points of intersection with a line and a circle, like so, then the discriminant is greater than 0, it's positive. If the discriminant is less than 0, negative, the line will miss the circle. And if the discriminant equals 0, then the lines are tangent to the circle. Okay, have a quick go at this. See how you get on. I'll pop the answer up in a minute. Okay. So solution to the first one then. Same as before. If we put our y value here, which is 2x in this instant, in for the y values here. Simplify. Look at the discriminant. We can see it's positive, so we'd expect 2 points of intersection. If we factorise and solve, we get 2x values. If we try these now back in the linear equation, we get our corresponding y values. So 0, 0 and 2, 4. Part B, same again, sub in the y value from the linear equation into the circle equation, tidy it up. It's a little bit more complex this time, isn't it? We're then looking to solve this. Let's observe the discriminant. We get 0, so that suggests a tangent. It suggests a repeated or equal root. We can factor the 5 out. That will help us. And we can see here that if x is 3, we have that solution. Put that into the linear equation, and the tangent is at the point 3, 3.